Now that we've completed the base installation of CME, we can move into the ePhones and ePhone DNs that define the entire network. This nugget and this concept is so important to configuring a Cisco Voice over IP network with CME. I'm going to give this the flag of importance. Now you might be thinking, what is the flag of importance? It's something I just came up with to say this is the most important thing. No, I take that back. This is the second most important thing you're going to grab from this entire series on configuring a voice network. See how I customized that flag there. You might be thinking, well, what's the first important thing? Maybe I should just make you find the first flag of importance through all the nuggets. No, the first most important thing is going to be the dial peers, setting up the route plan for the network, because that not only goes for this series, but it goes into the entire CCVP. That's one of those concepts you'll keep seeing again and again and again. But this one is huge for configuring the CME router. So, first, we're going to start off by looking at the foundation, making sure that all the pieces are in place, because we've done a lot up till now. You've got to make sure that we've got the infrastructure designed and ready to go. Second thing, we're going to prepare the CME for IP phone registrations. So right now, it's receiving the phone saying, "Hey, we want to register. We want a phone number," and the CME is saying, "Sorry, I don't support you right now. I have firmware, but I don't even know what firmware I'm supposed to give you." So then we'll define the ePhones and ePhone DNs, talk about those concepts. It's the name of this nugget, but it's also a major concept that defines the phones and the directory numbers in our network, and then we'll go through and configure it. Now, at this point, I'm not too sure how much I'm going to be able to squeeze into a single nugget. So somewhere right in the middle of this, we'll probably draw a dividing line and say, okay, we'll continue this in the next nugget because there's a lot of information to go through. Before we get into ensuring the foundation, I want to show you something. I just got it in the mail yesterday. It is my official CCNA Voice certificate and secret club card. I don't know what these are, but you get them for every certification that you get. Now, for those of you that are watching this years from the time that I'm recording it, this is breaking news. I didn't even know it was going to be called CCNA V as the acronym. I thought they might do a dash voice or a little subtext voice or something like that. But now I have the certificate and I have the card, which has a magnetic strip on the back. So maybe Cisco plans on allowing that to become like a credit card where because you're certified you can buy stuff and they'll pay for it. So that's pretty exciting. I now have the official certificate. What was I talking about? Ensuring the foundation. Let's start off by looking at where we've been so that can lead us right into configuring the CME to support these phones. First and foremost, it is key, and if you haven't caught it by this point, you gotta know the IP phone boot process. When you plug the IP phone in, it's going to detect the inline power support or power over Ethernet, send some electricity down there, send the voice VLAN to the phone using CDP as a transport. So the phone receives the voice VLAN number through CDP, now knows what VLAN it's on, sends an IP address request to the DHCP server that we've set up. So we've got to have our voice VLANs configured, got to have the DHCP server set up. That DHCP server also needs to give the phone DHCP option 150. Now this guy is the IP address of the TFTP server. So the phone now gets that and goes, okay, I'm going to the TFTP server, and that TFTP server has to be configured with the correct files. So at this point, with what we have configured, I've got a slew of IP phones sitting on my desk right next to me. The phones are now coming in droves to the CME. They're saying, banging on the door, let us in, give us a phone number, let us call each other. But this CME is not responding. Right now it's completely silent. As a matter of fact, the TFTP server isn't even configured with the correct files. We've copied all the support files over to the CME routers, but we're not serving them up to the phones as of yet. Now, before we can do anything with the CME router, there are 3 key commands that we need to issue to essentially engage or turn the power switch on the CME service. All three of these are issued from Telephony Service Configuration Mode, which is our home of CME. When we're sitting on the CME router, expect to live in this land known as telephony service. Inside of here is all of the core configuration for CME, and you can see right up front. It's kind of interesting. They say these are all the CME configuration commands. For detailed documentation, here's the URL. All of these affect CME and your IP phones directly. Now, the three key commands that we're dealing with is maxDN, maxePhones, and IP source address. These commands have to be in place before the CME router will register or even talk to any IP phones. So, the maxDN, when I type in maxDN, is the maximum directory numbers supported. Now, by default, this is set to 0, or it's zeroed out. The CME router does not support any DN, so we have to say, what is the maximum directory numbers, meaning extensions on your phones, that this router will support? Now, I suggest that on this maxDN number, you set it to a relative amount of what you plan on supporting. If you've got 30 phones with 30 numbers, set it to 35 or 40. You can always come back in and increase it just by typing in maxDN and another number. It's not like it locks it in there. But this governs how much memory resources on the router are dedicated to the CME process. If I just say, oh, well, I've got 20 phones, but let me just throw that in there, then the CME router is going to dedicate a lot more RAM and resources to the CME process than it needs to, and other things on your router may suffer. So, let's say we've got 30 devices. I'll set it to 35 to give a little buffer. maxePhones is the same way. This is the maximum phones that you are able to support. Now, this is also a great way to find out what is the maximum my router can scale to. By just hitting the question mark here, you're able to tell that this router, which my router is a 2801, which I love, can support a maximum of 30 ePhones. Same warning as before, don't over-provision this because of your resources, but one bonus warning in addition to that, Cisco says that you should only be setting this to the amount that you've purchased licenses for. Think back to the previous nugget when I talked about the licensing where you would buy the CME small license for 8 phones or 24 phones, and you can actually buy certain licenses. This is where you type in the amount of licenses that you've purchased. Now, keep in mind that Cisco does not monitor or require you to type in a license key code yet. So, as of right now, we now have maximum of 35 directory numbers, maximum of 24 phones. The last one is the IP source address. This says, what interface should I, if I'm a CME router, begin listening to requests from the IP phones? All of the IP phones have now an IP address, and they've been assigned the TFTP server address from the DHCP router. They're coming to the CME router, and we need to tell this router where should it be listening. Should it be listening on maybe a WAN interface or a fast Ethernet interface, or where these guys are coming in. Now, keep in mind that you can set the source address to any address on your router, but you can only have one. So, if you have a router that maybe is supporting IP phone registrations on, a network over here and a network over here, and maybe there's even some, it's not supposed to, but you can make it happen, some phones coming in across the WAN that are registering with this CME router, and it's supporting all those. Well, in that case, best recommendation would be to create a loopback interface. Now, if you haven't dealt with loopback interfaces before, these are just virtual interfaces on the router. Say you've got a router. Well, let me just use the real one. Say you've got a router that has all these interfaces. If I want to just have one interface that everything is pointed to, I can create a loopback. So I could go interface, loopback, and you can create a lot of these. You can see they're virtual. Just pick a number between 0 and 2 billion something. So I'll say interface loopback, I'll just say 100, and magically the router creates this loopback 100 interface. You see, poof, it came up. It's up and up. It's just a magical interface that appears that can be reached as long as the router is online. And I would give this interface an IP address. We'll say IP address 172, I'll just use .3.1 just as an example. And now I've got this virtual interface, and I would use this as the source address. So at that point, it doesn't matter if the phones are coming in from here, maybe come in on that interface, or maybe even come in across the WAN, some kind of internet connectivity or something to that effect. They're all coming to this loopback interface, and that's the one that registers them. If that were the case, I would go in and specify that loopback interface as the source address. But since all my phones are coming in from VLAN 10, that's Ethernet 0/0.10, I'm going to use that as the source interface. I'm going to do a no interface loopback 100 and kill that guy. So we'll do telephony service, IP source address, and it says what address would you like to define, and I'll say the source address where all my phones are coming into is 172.16.1.1. Now I can follow that up if I want to with strict max, like I want specific IP addresses or secondary addresses that I want to add as potential source addresses on here. This is very similar to like a secondary address on a interface. If you want to assign two addresses to the same interface, this is if I want to use two addresses for registrations, or I can specify ports or anything like that. But all in all, doing that is sufficient. Just typing in the IP source address command with the IP address uses the default port. This is the skinny client control protocol, or SCCP. That's the protocol these phones are using when they're talking to the router. It by default uses port 2000, and so you don't have to change it if unless you're doing some strange custom stuff. That now has our CME router running with the 3 core key commands. It's now ready to accept registrations. In order for the phones to reach the CME router, they need to have firmware. They need to get firmware from the TFTP server. Now, who is the TFTP server in this case? The CME router. So the phones need to get to the CME router as a TFTP server to get their firmware to learn how to get to the CME router. Some strange catch-22 in that way. You don't have to use the CME router as a TFTP server. You can actually set up a little TFTP server on a workstation or server somewhere that gives the firmware files to the phone, but I will say CME was designed this way. It was designed in such a way that it was assumed to be the TFTP server, and most people use it that way, so you don't have to have a separate server for TFTP services. So, let's go there. I'm back on the CME Voice router. And you remember from the last nugget, we set up all of those CME support files in Flash. So let's look. I'm going to do a dir flash, and remember last time there's our iOS, ACD prompts, and so on. You see this directory called phone. Under that is where all of the firmware files for the phones are. So I'm going to do a dir flash /phone. And you can see underneath that is all the subdirectories for each one of the phone models that the CME supports. And you can see that's just about all the models Cisco makes. And I'll hit the up arrow, and let's say I just want to support the 7940 and 7960 IP phones. They use the same firmware files, so Cisco groups them into one directory. And right there are all the firmware files that the 7940 and 7960 support. Now here's the problem. The CME router is still a router, and a router is not a TFTP server by default. So the first thing that we need to do in configuring this is to specify the files that the router will supply via TFTP. So I'm going to go into global config mode. I'm going to type in TFTP server. This is how we make our router a TFTP server. Do the question mark, and it says, where do you want to get the TFTP files from? And I'll say, well, they're actually in my flash RAM in a directory called phone, in a subdirectory. Matter of fact, I could just copy and paste this guy in there, 7940, 7960, and the first file that I'm going to serve up is this guy. Now you notice under this subdirectory is all 4 different files. You need to make all 4 of them available through TFTP in order for the phone to get them. They'll use all those files at some point. One is the firmware, another is the load file telling them what firmware to use, and all that. One of them is a secure firmware that uses a cryptographic image, so it can't be counterfeited and that kind of thing, but the phone needs them all. So I'm going to right-click and say, make that file available. Now it's kind of a pain, but we do have to do this file by file. So for the 7940 and 7960, I'm going to make those 4 available. I'll do a question mark. And it says, you know, do you want to filter it with an access list to say only certain hosts can get to it? So if security is an issue and you don't want people getting your phone firmware, you might want to throw an access list on there. I've never done that myself. But you do want to follow it up with alias. And I'm going to say the alias for this is this. Now that seems a little odd. I'll hit the enter key there. What's that all about? Well, remember, as of the new versions of CME, the Cisco decided to organize the file structure of Flash into subdirectories. It wasn't but a year ago that this happened, because before it was just all one flat structure. All of the files that you saw when I did that show Flash in the previous nugget, and just tons of files, would just be all in one flat directory. They'd be right in Flash. So in the old days, it was a mess in your Flash, but the good news is that, you know, the files were right there. It didn't have this directory to weed through. Now when the phone comes and asks the TFTP service for its firmware, it's just going to ask for this file. It's not going to know what directory it's in and subdirectory and all that kind of stuff. So what the alias does is tell the CME router, hey, when somebody comes in and asks for a file, if they're asking for this file, give them this one. The one that's actually in all these subdirectories. So this way, the phone doesn't actually need to ask for all these subdirectories to be there. You know, it doesn't need to know the full directory path. That's a better way of saying it. It doesn't need to know the full directory paths. It can just ask for the file, and the router will give it to them. So I'll hit the up arrow, save myself a little typing, and I'll make the second one available. And I'll say alias, put that in there. Hit the up arrow, make the third one available. We'll say this guy, alias, and that guy. Oops. Alright, one more. Hit the up arrow. You can see it's kind of tedious, takes a little time, but once you've got it, it's done. I'll say alias, put that in there. Good. So now, if I do I'll do a show run include lines that have TFTP server. And right there's the summation. This makes all of the firmware files available for the 7960 and 7940 IP phones. You'll need to repeat that procedure. Do the same thing for every model of phone that you have. Now, I'll give you an example. I won't go through all the commands. I'll do it when I pause the video, but I don't want to make you sit there and watch me type all these commands. I'll do a dir flash :/phone again. And let's say I've got 7970 phones. Matter of fact, I have one right over here. So I'm going to say, show me the subdirectory of this. Yeah. You see that, and I'm going to have to type all that in. I won't make you watch it, but I have to make all of those available to support 7970 and 7971 phones, because these are all the Java files. You can see this is a Java file that it supports. The 7970s and 71s support a lot more applications than 7940s do, and the full color screen adds files. So I need to go through and do the same thing for all of those commands. Pause. Unpause. Okay. I've typed in all of the TFTP server commands to make the 7970 and 71 firmwares available. So now at this point, when I do, click in here, a show run include TFTP, I can see that I'm serving up all of the 7940, 60, 70, and 71 firmware files via the TFTP service. Now the last thing we have to do to make these phones aware of what firmware they're going to use, is to configure the CME router to tell them. It's done using the load command. When I type in load under telephony service, you can see I can specify the load for any model of IP phone that the CME router supports. So, for instance, I was just specifying the 60 and 40. I type in load 7960 and 7940 and hit the question mark. It says, what is the firmware file name for the Telecaster, that's the old name, 7960 and 7940 IP phones. I scroll up, and notice it says without file extension. So I scroll up to my 79, 60, and 40. You saw I did right here. I did the dir command for flash, and notice the file name. All of these file names, the bin, loads, SBN, SB2, and SBN, all start with the same kind of global firmware file name, if you will. So that's the one that I'm going to right-click and copy and paste over here and specify as the firmware file for it to load. Now, as soon as I do that, it should have said something there. Hang on. Do terminal monitor. Oh, wait, no, it's not going to say that yet. Hold on, please hold. You're going to see where it's going to talk about configuration files and things like that. That comes later. So I've got load 7960, 7940. Here's my firmware file that I've specified. Now I've got to do the same thing for the 7970 and 7971. So I'll do load 7970, hit the question mark, same thing. It's saying what is the firmware file of choice. So I'll scroll back up here and say I am going to use the SCP 70 8-3-3s.loads. Right click and paste that in there. Enter. And I've now specified that as the load for the 7970, and I'll do the same thing for the 71. There we go. I know it. I feel it right now. You're looking at that going, how did you know to do that? How did you know to specify that file name out of all the files that are there? I mean, with the 7960 and 40, it made sense because they all have the same main file name, just different extensions, right? But how do you know when it comes to the 79, 70, and 71 to use that one instead of, term 70, term 7, I would have thought to use term 70 or one of these DSP files. I mean, where did that come from? Well, I'd love to tell you that there's a formula behind it that I can look at and go, well, because it has a S at the end, or something like that, I can tell, but there's not. There's unfortunately no formula. You have to go to the Cisco website, and the best way to find this page is to search for it. Just search for Cisco Unified Supported Firmware Platforms, Memory, and Voice Products. Just type that whole string without CME 7043 in there, and you'll get to this page. And the reason I say drop this out is because they're always coming up with new CME versions. Like this is insane. This just happened since July 11th. That was, what day is it? It is August 5th right now. So, a couple weeks ago, they upgraded this to say 7.0 now. And when I came to this, at first I was like, what? 7.0? How do you go from 4.3 to 7.0? That's like, let's just skip 50 revisions right there. Well, right here it says, Cisco iOS may inherit Cisco Unified CME 7.0. Note, CME includes the same features, meaning it's the same product, but it was just renumbered to 7.0 to align with Cisco Unified Communications versions, or the full Cisco Unified Communication Manager. The irony of this whole thing is they haven't come out with Communication Manager 7.0 yet. They're still on 6.0, unless tomorrow, because I had to go check. Tomorrow I'm probably going to go, and they're like, oh, Communication Manager 7.0 is out. So, this stuff moves like mad. Anyhow, this page, if you scroll down, notice it just says supported platforms, memory, and so on. This page shows you every single product that Cisco has, the phone, what it supports. And you scroll down to the model that you're looking for. Like right here is 7940 and 60. It says this is the firmware or the file name that you need. When you scroll down to the 7970, notice it says here's the files or the firmware files that you need. This one with the little star on it, that's the one that you need to make available. So the little asterisk on all these denotes which load file to make available. So you can say as a general rule to make the one that says sccp.loads available for whatever model you're looking for, because you can see the little asterisk. But I'll keep that a general rule because that's not always the case. You can see, there's other things that use different file names and so on. So that's where I go to always find out which file to actually use and make available. So with that, we've now made the firmware version available using the TFTP command, TFTP server, and using the load command. Now that we have that base configuration in place, let me show you one more key command. And that is going to be, I'm going to go back to my telephony service configuration mode and type in create CNF files. This creates the CNF files for the IP phones. Remember I said, think of the phone boot process, gets its voice VLAN, goes to the DHCP server, comes to the TFTP server asking for its configuration file. That configuration file will tell it what firmware to download. It tells it what the call manager's source IP address is that it's going to find the call manager. Now you might have noticed when I hit that, you might not, but there was a slight pause when I typed that in before it said creating CNF files and my prompt came back. That was because it actually generated behind the scene these XML configuration files. Let me exit out here. I'll do a show telephony service and we'll do TFTP bindings. Because, now remember, I made some of the firmware available using the TFTP server command, but the telephony service, the CME service itself, has its own TFTP bindings, or files that it's making available through the TFTP server that I don't have to type. So when I type in, show TFTP bindings, it comes up and says, hey, I'm making available from the system. The system directory, by the way, is RAM. That's the RAM of the router. So if the router turns off, all this stuff goes away and has to be recreated the next time. But you can see that I've got the 7960 tones, uses an alias saying, 7960 tones, fonts, font, dictionary, Kate. I'm not too sure what Kate is, but these are all XML configuration files that helps the CME router support the IP phone. Now you notice down here we have sep default, then we sep default config alias sep default CNF, XML default config.xml, and then we alias it right here. These are what is known as generic configuration files. These files are a base configuration that the router has for any IP phone that comes and registers. Now remember, these IP phones don't have configurations yet. They don't have directory numbers. I haven't set them up. All I've done is said, here's the firmware that they're using. So let's dig in and let's look at this. Some of you from the Unix or Linux realm might know the more command. Well, the more command works on the router as well. It's kind of like the type command in DOS on Windows, or it's like Notepad. You can see what's in a file. So I'll say, show me more, or show me what's in that configuration file. Hit the enter key. Pause. It comes up and says, okay, we've got your call manager group. This is XML, by the way. XML looks very similar to HTML, where you have like an open tag, for call manager information, close tag. Interesting that while they have renamed call manager to communication manager, it still uses the call manager tag in the XML file. So you can see this is the default port number, the skinny port number that it's using. This is the source address, 172.16.1.1. Now remember, oh man, this is getting good. Remember, we set up the source address. We typed in IP source address. I'll just put SA to 172.16.1.1 in the telephony service config mode on the previous slide as one of our key commands to type in. And what that does now is when I created those configuration files, it put it inside of this configuration file, which is given to the phone. Right? The phone's booting up and it says, remember our boot process, phone comes to the CME router after getting option 150 and says, give me a configuration file. So the router says, phone, here you go, and delivers this file to the phone, default configuration file, because we haven't configured any phones yet. Now inside of there, it tells the phone where to go to reach the call manager. It also tells the phone, look further in this config file, what firmware to download. If it's a 7940 or 7960 phone, notice it says, here's your load information. And notice as well, for the 7935, 14, 10, load information is blank. There's nothing in between those little brackets. But for these guys, it says load information is this because that's what we typed in before we created the config file. Look at the 7970. There's that load in the 71. See that? So when these phones register, they get this configuration file, which tells them exactly what firmware to ask for from the TFTP server, and exactly what IP address to access to reach the call manager. So all of that is displayed, and we can verify that that is operational on our CME device. At this point, we should be able to go to our IP phones and see that they're receiving that and quote-unquote registering with the CME router. And now I say quote-unquote because they don't, when they register, they don't get anything, meaning they don't have phone numbers yet. That's when we configure the ePhones. Let me show you this just to show you where we're at this point. I just booted up the Cisco IP communicator on my PC, and it registered with our CME router. This is its default state. Matter of fact, I'm going to reboot this guy just so you can watch it register. To reboot a Cisco IP phone, any IP phone, physical or on, soft phone like this, you hit ** pound ***. And that forces them to reboot. You can see it's resetting. And the physical phones take a lot longer to boot than this guy because he's got the power of a computer behind him. Shows registering, and poof, there we go. Notice it shows accurate date, accurate time because we set the time using NTP. We've got new call, call forward all, all these different buttons which kind of blink, and it says it shows a speaker here, but nothing's coming out because there's no lines on this phone. This phone this is considered auto-registered. It has auto-registered with the CME router, but at this point it doesn't actually have any phone numbers, so it's useless to us right now. I'm going to scrunch this guy down to the compact view for future nuggets, just so you can see, and we may bounce back and forth, but this helps me keep them open and eat up a lot less screen real estate. So I can actually go over to my router now. And let me just hop back over there. I had to jump over to my switch to put my PC in the right VLAN. But I'm going to do a show ePhone. And right there, this shows that I have one phone. That's this guy right now registered. It recognizes it as a Cisco IP communicator. You see that right there. This is my IP address on my PC, 172.16.1.50. It is registered. It is locked and loaded. Now my other Cisco IP phones are there and they're booting, but I have the wrong IP address configuration on them. So they have, as of right now, are still boot cycling. But I've got the Cisco IP communicator working, which proves to me that our CME router is set up correctly. So at this point, we now have the foundation put in. That's where I'm going to draw the line in the sand on this nugget. Because if I throw in ePhones and ePhone DNs, it opens a whole can of discussion that's going to take quite a while. So that'll be in the next nugget. So just to wrap this one up, we have talked about the foundation of what you need to get running and preparing the CME for IP phone registrations, mainly focusing on the 3 key commands that you need, the max DNs, max ePhones, and IP source address, and then looking at making the firmware files available both through the TFTP server portion of the CME router and through the load command from the telephony service specifying which firmware file to use. I hope this has been informative for you, and I'd like to thank you for viewing.